Geometric Optics 7, convex lenses. A convex or converging lens converges parallel paraxial rays of light to a focal point. Okay, I'm going to draw an example of a convex lens. Okay, here we have a convex lens. Now, let's go over the anatomy of this convex lens. So, first, we have a real focus. A real focus is the point where light rays actually focus towards. Okay, it is some point on the other side of the lens. So if I'm looking through in this direction, my real focus is going to be at some point here, and we denote that by F. In addition, we have the principal axis. That's the line through the real focus and the midpoint of the lens. Okay, so we consider some point here the midpoint, and this is just a straight line going through the principal axis. In addition, we have the focal length is the distance from the lens to the focus. Okay, and that we note that by lowercase f. And then finally, we have the optical center, O. Okay, and that's the center of the lens. Now, rays going through the center, the optical center, are undeflected and they do not refract. Okay, so all rays going through the center go straight through the center without refracting. Rays of light that enter in parallel to the axis, okay, so this is entering parallel to the axis, will refract and go through the focal point or the focus. Okay, so parallel lines, they'll refract to the focus. Lines going through the optical center will not refract.